Okay, everybody. Once again, like usual, hopefully this is working. Okay, so we're going to start visualizations. This is actually a short slide deck. I might do a second one. We'll see what questions come out in the Slack. There's specific things I think we need to recover. Visualization is kind of, it can seem kind of common sense in a lot of cases. So it doesn't really require a ton of direct instruction to really get the basics. More useful is to actually see it in action. So we'll go through some of those, some ideas of other ways you can use them in a little bit. So going into just recap stuff. So GOMS, this has kind of been a great, that bullet and the next bullet updates to questions. So I really liked, Shirley's asking all the questions about a lot of the acronyms and stuff that I threw out there. That was extremely useful because, and we talked about this, or if we haven't, we will, the false consensus effect. So the cognitive bias that what you've experienced, other people have, and they've experienced it in a similar way, all those things. This is a great example of that. I try to be relatively sensitive to the weirdness of the acronyms, but I definitely miss some. And obviously GOMS was another one. So keep that in mind in your designs. What you're thinking most of the time will be biased in favor of what you have learned and what your kind of natural thoughts are on some of those things. So be aware, just kind of as you're going through, that's one of the easiest ways to dodge issues on your designs when you get to user testing. Okay, let me scroll through here. Oh, and really quick, sorry. GOMS, yeah, I saw there was on one of the threads discussing it. Nathan kind of explained it as kind of like breaking down tasks into basic components. That is very much what it is. So good job, Nathan. We talked about it with, I think you called them basic tasks, or when you can deconstruct a task into, all physical motion is, a subset of 7 actions or whatever that number is, pulling, pushing, lifting, etc. It's kind of like that with cognition, where there's not like a limited number or anything, but you are essentially trying to break things out. And instead of just a basic task analysis where you want to break out every single step that could be, you want to break out how the cognitive process will unfold. And that is really helpful for your design. So an example I pulled up, I still have that here. So if we go into GOMS and just search in images, we'll find, add example here. Mary posted something kind of along this line, this pseudo code looking almost like the instructions you'd give to a computer. It is definitely that. But also this, I was just going to type it out, but then I saw this one. So this is the way to break it down. So, and you should be able to see that this could be very, very important to design. If you can break out what your users are actually trying to do along these lines, some of these, so operators would be user actions that we need to make sure we support. Methods, that's information architecture and process flow. Does it make sense in the way that does the sequence make sense logically with the operators are doing? So this kind of breakdown can also be super useful for that. And then, so we've talked a little bit about HRA, or human reliability analysis. There's a GOMS version of it. And there's also the Hunter dynamic HRA method that relies somewhat on GOMS at some different levels. So that's something to be aware of there. I'm going to go through some of these. I like the objective measures comment or post here, Mary. Yeah, cortisol level spit swabs are gross. So that would be nice. It's always great if we can get objective measures like that as needed. But we deal with this in HRA and human error monitoring. We'll look at, okay, well, what does stress mean? We tend to think stress means poor performance and high workload is poor performance, but not necessarily. It kind of depends on your situations. What Mac did I get and why? I got the new M1 Mac Mini. Reason why I was going to get a new gaming PC and ended up getting an Xbox Series X. So kind of it would be redundant, but I did need a new home computer, and it was probably the fastest one I could get for the lowest price. If I'm not using it for gaming or whatever, I didn't want to sift through the million different Ryzen and Intel 10th gen chips to figure out which one I wanted. So just a little bit simpler. It is my first Mac. I habitually and almost ritualistically hate Apple as a company. I think I take a weird approach in that I think they've been phenomenal for industrial design in some, well, let me requalify that. When they have been great at industrial design of products, they have been really, really great. When they are bad, they are really, really bad. Like the Magic Mouse and the fact the charging port's on the bottom. And I also tend to think that the whole Steve Jobs idolation or idolatry, I would say, has done more damage to design fundamentally than I think any venture capitalist could. So I tend to take a pretty strong opinion there, but it was a good price. It works, and it makes sense to have. I have Windows and Mac and Linux machines now in my house, so my kids can kind of learn different methods and whatever. I have found just problems, lack of freedom and stuff on the Mac that I always knew were there are really problematic to me. I'm somebody that if I can't get my computer to do what I want it to, I will just open up a command line and force it to do it. So you can do that on a Mac. That's actually somewhat a little bit easier. But when I have like a pop-up that I'm trying to close and like just actually today I hit a button and on my headphones and I got a pop-up for Apple Music or it launched iTunes, one of the most horrific programs ever created. And I was like, oh, I didn't mean to do that. So I went to close it and there's this immediate pop-up of, hey, it's the first time you've opened up Apple Music. We're going to give you a spiel about nonsense. There wasn't like an X on the pop-up. There was just the button that said start listening, which, okay. But I was a little bit hesitant to click on it because my immediate thought, is this going to send me to a payment page? Are you going to charge me money for this? And which is a great example of knowing the ecosystem you live in. Apple has a tendency to view everything through the Apple lens. So no, we don't need to do that with our design because we're Apple. So other designs don't matter. Well, that works, I guess, for some people, but in my opinion, if you think, well, we're not going to charge you money, so it's okay to just leave the button there. Well, everybody else charges us money when we hit those buttons, so know that and give us X, or just say change the text of that button to something more simple instead of trying to be kitschy. I think that's a useful thing. But otherwise, it's been working fine. The weirdness of using Rosetta to get 30 or 64-bit Windows applications on a mobile chip's been interesting, but otherwise, haven't had any huge problems yet. So let's see. And then, yeah, I like sharing the explainable AI stuff. That's one thing I wanted to stress, right? Explainable AI is a human factors problem. So it's important to understand that. Going back in the GOMS example, yeah, we talked about that a little bit. So surely like an example could be, walking to, or you're walking to a parking lot, you need to get into your car. Your goal is to enter the car. That's your big goal. You have sub goals. You have to get your keys. Maybe you have to unlock your car. Or if you have a car like my old car, you have to unlock the passenger side of the car in order to reach over and unlock the driver's side manually with the little with the pulling up on the lock knob. So breaking it down to there, your operators are the specific tasks you need to do: dig in your pocket for your keys, place a key in the lock, etc. And there are the methods. There's an order to that. You don't try to put the key in the lock before it's out of your pocket, and that's kind of a way to break it down. But yeah, I did like that example, and Nathan, I think you got it great, and same with you, Mary. So female operators in terms of workload, female anything in nuclear is hard to find outside of ergonomics, because the mil-spec standard has done, or not mil-spec, mil standard for ergonomics has done a very good job at collecting anthropometric ergonomic style data for genders, age, all sorts of stuff. We have a ton of research for that. I'm still pretty new to this. I'm trying to think if I know of a woman who has an operator license or had one, because I work with a lot of people that are now in research that were in operations, obviously, at some point, and I can think of a few former operators that had a license, and some that still do, but not so much women. So I would wonder, I'd honestly be interested if the NRC even keeps, they're the ones that issue operating licenses, if they even keep data on that, on demographics of operators. That'd be interesting to look at. But yes, I would also say that my assumption is that as a general thumb, error or any research on females is not enough. It's not done well enough. It's not done just quantitatively enough. This is a big thing when you look at Wanda Sykes did a stand-up bit about how she was having a heart attack and they sent her home with ibuprofen. It's pretty funny, but it's also serious in the sense of heart attacks present differently in women. We're starting to see that. But yet medical schools traditionally only use male cadavers. So that's a huge blind spot for the medical industry. And I would imagine psychology has a lot of those same ones. So, and nuclear, which is an offshoot of the military, even more so. So none that I'm aware of in terms of workload. Honestly, research on workload in general, not super great. That's definitely a problem we deal with too. It's kind of arbitrary, specifically in nuclear. If you want to get some more of that information, look up whatever you're trying to search and pull NASA. As a general rule of thumb, NASA's kind of our initial stop, is to look at research that they've done in terms of people and how they perform in various scenarios. You also would probably have a better shot, probably a decent shot actually, of finding data on, or at least information on females. One thing you won't find on NASA studies a lot, you'll get a lot of anecdotes or breakdowns from the studies. You won't actually get the data in tables or any of that we're used to seeing. Reason for that is there's not that many astronauts that are qualified. So it would be really, really hard to anonymize 50 people, So that's especially if you had a bunch of scrubbed data, but you had height, weight, race, age, like you could probably figure out who most people are. So that's part of why they don't tend to release it as well. So some takeaway, but there usually are some really good breakdowns of the people participating in the study. X amount had this, X amount had this, but you don't usually just see the raw. Let me see here. Yeah, so ahead of the visualization lecture. So this is an example of just the consensus effect, against different than false consensus. We can't figure out how to name anything in a good way, apparently. So false consensus effect is everybody has the same experience as me. It's kind of like consensus effect in the sense of your visual processing system is, if it sees a bunch of similar objects, it will try to lump them in with characteristics that fit different visual schemas or expectations. So, and another fun trick, you've seen it. So you've looked and, oh, they look upside down. And then you see one of them that does not look upside down and or isn't in fact upside down. And all of a sudden they all shift immediately. Look away. It only takes about 10 seconds. Do it again. You'll see them all flip back upside down. And then when you see that other one, they'll switch again. It shows the decay of our visual memory. That's another thing to be aware of. So when we look at visualization, it's important to think about how we visually process our environment. I read an article once about visual cognition, essentially being seeing the environment, or no, flip that, feeling the environment with our eyes, which isn't totally wrong. When we use touch to navigate an object or an environment, we're seeking edges. You know, you want to, that's how you understand how bounded the product is. If you're holding a box, you need the edges, and then you can figure out roughly how big the box is with pretty good accuracy. You can start to visualize the box and those kind of things. Your eyes are doing a similar thing. They're seeking edges and shadow. That's how we understand shape. So it's an interesting an effect to understand, you know, because especially in visualizations, we are essentially hacking, we're exploiting our visual system's power to understand information a lot faster and a lot more of it at once. Because if you think about how much information jumps into our brains at any given moment, you know, you're talking about millions of data points every second. And we process it seemingly fine. So definitely something to keep in mind as you're starting to develop that. And yeah, and if this really blows somebody's mind and they want to explore an interesting question for that, for like a midterm thing, that's great. Speaking of midterm stuff, we talked a little bit about due dates. I think I can't recall immediately when spring break is. Let me look. Oh, I don't want this. I want a new one. Let me just see. Calendar. That'll work. Okay. Spring midterm grades due next Monday, and next week is spring break. Okay. So let's have midterm stuff done over. Let's do that like a the following week. Let's do. Let me look at my calendar. Yet another thing I am now learning again, all over again, is how to use a calendar on this. Let's check my phone. Okay, so if next week is spring break, let's say the 26th, loose date, 3/26, have whatever it is, whatever you're going to do posted, and we can start talking about it. And if something happens or you can't make that or whatever, just let me know. We'll talk about it. We'll figure out something. So I think that's mostly all of it. Good engagement. Just kind of keep it up. I try to check into this every few days. Yeah, and I'll try to share some more of those funny things. I see or get sent a lot of weird user experience or design things on Twitter and just around. So I can usually come around with a few of them. So, okay, so jumping into actually the lectures, I'm not going to do the whole slideshow thing. I think I recorded the wrong display last time, and I don't want to deal with that. So this should hopefully be big enough. If it isn't, I'll re-record it. I don't know what I'll do. I'll figure something out. So we design visualizations because of the efficiency of data processing. We're using pattern recognition and the visual processing speed to consume vast amounts of data immediately. Also, you can design them in a cross-cultural sense, which means your user research can be a little bit more powerful as you start to explore different visualizations if you're doing something novel. So here's an example of a topographical visualization of an ocean floor. So think about the data points that are in here. It looks like one image to us, but we have color, which appears to be linked with elevation. We have, or maybe it's temperature, who knows? It's something that is that has a difference between the top and the bottom. We have different peaks and valleys. Those will all have data points of height, width, different geometric data points to be able to map it. And we can see, it looks like it goes down farther. We start to see purple down there in the very far distance. So we know it's continuous. It also resembles mountains or valleys that we're familiar with, canyons. So we maybe have schemas or different things that we're pulling from for that. And all of that we did immediately. Where if you had let's say an Excel spreadsheet or a set of them of all the data it took to build this image, and try to understand what this image is trying to tell you, what the data means, that's a concern, and you will take further. You'll be doing it for years. So that's primarily why we do that. Stages of visualization. Some of this is from a book called Information Visualization, Perception for Design by Colin Ware. Really, really great book, breaks down a lot of good stuff if you're interested in more of this. So this is kind of how we visually process, how we visualize things. So we have raw data. This is in the sense of contrived data that we're trying to visualize in a system, or raw data walking down the street, just the sensory stimuli that are you're being bombarded with. We have data tables. That kind of gets managed immediately by your low-level processing in your visual system, but we kind of do a similar thing, categorizing it. We start to map it onto various structures, things that we've experienced before, and then we get views. Now, the user at the end there will want to interact with your visualization that you design at various states. We may want to transform the data at a certain point. Oh, this system imported the data, and this is it changed the format of this. These are actually whole numbers. It changed it to dollars for some reason or whatever. So we have to transform the data there. We also may want to change visual mappings. This could be color, this could be shapes, styles, different things like that. And then view transformations. This is, I'm looking at this view, but I want to interact with it in a way that will change the others. I'll show you that as we get farther. And just kind of similar breakdowns. The image on the right captures the same information, just a little bit of a different image. It is pretty hard to read. I could not find a good image that would actually scale well. I even actually opened up Photoshop for the first time, tried to see if I could get it to work, and alas, it did not. So if you have any questions about any of those boxes that you can't read, let me know. So are pictures arbitrary? Do they have innate, unique characteristics? So when we talk about arbitrary, we're talking about things that their meanings or their notions, kind of what makes that idea, what gives it its depth and everything is arbitrary. It has been given that by somebody else. It doesn't have anything. It's not bringing anything to the table, let's say, to adjust that. So words are arbitrary. There's maybe, I guess you could say, auditory, when we're trying to recreate auditory things, maybe there's something there or whatever. But in general, when we say, oh, this is a computer, that's just an arbitrary name we gave it because it computes things. It doesn't have any inherent view. Computer doesn't describe a shape or something that might be inherent to the object. So visual system differentiations between pictures and reality. That's actually an interesting question. And then if you ever really want to fall down a dark rabbit hole, there's philosophy of art and semiotics, which explore a lot of that. But here's some really huge examples of how even pictures can transcend and connect with reality in some real ways. So this first study, they have some children and adults in Zambia that did not have a lot of experience with graphical representations. They don't really have pictures or any of those things. They were able to easily identify real objects from a picture of that object, which seems very common to us and common sense. But if you've never seen a picture before, aside from the sheer sorcery of it all, you're only seeing one perspective. What if they present the object from a different perspective? In general, we can still connect that, and that's an interesting thing. And this last one, IRB alert, 100%. This would never fly now. We talked a little bit, or I think I talked to one of you about the Milgram experiments that also would not fly nowadays, but this one is wacky. So these two researchers, Hochberg and Brooks, raised, I believe it's their child, without pictures until the age of 2. There were no pictures in the house, and they constrained the environment such in that way. And then when the child was 2, they could still identify objects from pictures. They could still connect it, even though they'd never dealt with pictures. So there does appear to be something inherent to pictures and to visual images that transcends experience and cultural differences. So this is the way we're going to use these terms. So if a visual item or element is sensory, that means that it possesses something that connects it to, that the brain can handle without learning. So an example is a circle is a bounded region. When you see a circle, you fundamentally understand there's an in and an out. There's a barrier there. There's a fence or some kind of restriction on that space for whatever reason. But you fundamentally understand that. Just as we fundamentally our brain, our visual system can process an image of an object and connect it with an object in 3-dimensional reality. And so that's your golden goose there. If you can create visualizations that are sensory more than arbitrary, you're in a good spot. Lower training needs, all sorts of things. Arbitrary are ones that we have to teach. They don't naturally possess something that is that your visual system can manage. We have to give your visual system through learning a schema to understand what to do with that information. So dog as a word has no perceptual value relative to the animal. It's just a chosen name. It doesn't describe a shape or anything like that. It's just a name that we then have a schema that matches that. But if you raise, and we've all experienced this, right? If, especially with people that are learning, let's say English as a second language, and I'm sure it's the same if we were learning another language as a second language. You might learn a word and ascribe it to an object, and you get it wrong. And then you just go through your life. This is something even natural born speakers probably do, where you go through life thinking, oh, this is that. This is one of those objects with that name. Come to find out it's not. You can learn the false characteristic, or you can learn the false representation of it. That isn't possible with sensory things, where I won't say it's not possible. I guess there are instances where brain damage or different problems could cause something like that. But as a general rule of thumb, that's what we're talking about then. This is exactly what we're talking about. As is often the case, we go to monkeys to prove things in psychology. So one of the things that's been shown by a lot of different studies, so impairment in monkeys, similar to those of humans, there's been research where they look at brain damage to different areas of the brain, brain damage of different areas of the brain, where it affects how you perceive images. In particular, it is V4 right over here. This is usually where, if you have brain damage there, you will have visualization issues. And that is common in monkeys as well. So we do see there's also a neurological handling of visual elements that would make sense considering the speed at which we process and how consistent they are across our species. So that's one of the things to keep in mind there. So some of the basic fundamental characteristics, if it's a sensory visual element, you can understand it without training, you can understand it immediately. You have resistance to alternative explanation. This is a fun thing with illusions. So somebody can tell you that that line is longer than another line, for example, when in reality, they're the same. As you learn and they correct it and say, nope, they're the same. You can break out a rule or whatever, you still might perceive it that one of them is longer than the other. And that's a characteristic of a sensory representation. Our visual system is powerful, it's not always perfect. We actually have one of the weakest visual systems in the animal kingdom. Now, arbitrary representations are hard to learn, they require training. They're easy to forget because they have no inherent grounding or anchoring to other things. And they're embedded in culture and use cases. So if you have a diverse user population, then that's going to be problematic. You're going to have to really test that with some extra rigor to make sure that you capture users across your population. Affordances. So affordances in usability is a characteristic that a thing's used is immediately understood by your perception. So the famous Norman doors, this seems weird. We could still push with a handle like this, but it's not the first thing we would tend to do. So Gibson's affordance theory is usually, its full title. Argue that perception is a tool for operating on or within an environment. So digital affordances are a weird thing. Do they exist? Can they exist? It's a weird question that so far seems to be kind of a no. We think that they might, but that's generally because of our use case. If you present somebody who's never dealt with a digital system before, with a computer, a display with buttons on it, let's say, they may not know fundamentally that they need to click on those, or that they can even interact with them. They might just be seen as decoration and those kind of things. So they do seem to have more power than, an absence of an affordance completely. I don't know why I'm getting my text message notifications on here. I'll fix that. But they do seem to have some power beyond just the traditional, beyond the traditional, a situation where there are no affordances. So they don't seem as strong as physical affordances, but there's something in the middle there that they seem to occupy. Maybe it's because they are based in culture and use, but over time they become so ingrained that they take on this middle ground area. It's a little bit unclear. So that's definitely one of the things that's an interesting area of research for some of this. And it's important for us as designers. We want to design things that people can use immediately and successfully. Okay, so going to the visual system. So this is the process that goes chronologically. Your baseline elements are pulled from a scene. So this is your taking raw data and data tabling it, right? We're looking at doing that initial first cut of what is going on and what is the circumstances of the situation. Pattern perception comes next, and then visual cognition. It is possible to just have a situation terminate before it has to move on. We deal with so much visual stimuli, not much gets to visual cognition level, where we actually have to actively interact with this information. And remember, oh, that's just having an extra. The visual system is trying to predict what comes next. That is a big thing people tend to forget. So that is why your users might make odd actions. They're doing good, and then they jump and make some weird error that you weren't expecting. That can be because of the predictive nature of the visual system and of cognition in general. We don't have the brain power to be able to handle everything immediately as it comes in. So we try to make predictions and shortcuts and heuristics to manage. That's also why we pull full schemas and just from memory. We don't tend to, we're not pulling bit by bit as we progress through a situation. So here, what's the baseline elements you pulled from the scene here? Grass. And you might have seen this. Probably did. If not, your pattern perception would have caught it. Hopefully, mainly because this lion's snout is up. If it was down, you might not have. So that's how camouflage works. It's trying to fool this level, then it's trying to fool this level. If they can camouflage in a way that their pattern matches, this is beyond just a chameleon turning the same colors as a leaf. The shape, the shadows, those things really, really matter to match the overall pattern. And if not, hopefully visual cognition will save you. There's a reference in, I don't know if I've mentioned it. If I have, sorry. It's one of my favorite kind of crossing pop culture and what we do all day. And it's a line from the first season of Fargo with Billy Bob Thornton, who's an assassin. And he turns to one of the police officers played by Colin Hanks and says, do you know why the human eye can see more shades of green than any other color? Because the cop's trying to figure out how he can do what he can do. Like, how are you lying like this and all this? And he said, when you have that answer, you'll understand. And the reason why is so that we can detect predators in forested or jungled environments that are predominantly green. That's an evolutionary thing that has happened to us over time. And that's also why our visual system works in this way. Primarily, this baseline elements, we want to know if there's danger. We want to avoid danger at all costs or know what we need to do in the instance of danger. So pieces of a visualization. This is, we're talking about this. This is not the cognitive process. This is what are the pieces of an actual visualization you may build. So a dashboard or a data representation. We have data, which can be all sorts of different, there's a lot more. But you need to understand the data you're managing and how it can be represented. Interactions, these seem weird, but we will talk about them when I can show you an example. Explaining a topic like brushing is kind of hard without an example. Like I can explain it, but it's better to see it. Text, so titles, descriptions, different things. Text still has a place in visualization. Relationships are a huge one. Your visualizations have any power, you need to be able to show relationships and enable users to find their own. And your overall design in terms of like a framework. So what's your canvas layout? When you're building a visualization, your canvas is, think of it like a desktop. It's a limited range of space where you can put your visualization items. Colors, visual choice is a huge one, and also can sometimes be culturally significant. So an aspect of visual choice could be that, okay, what's important needs to be on the top left or the top right. That's just, especially if it's a digital system, that's where we tend to think. In English speaking cultures, top left is where we start reading. In other cultures, in Asian cultures and what, there could be a different starting point. So being aware of that and where your users may go first is important. If you can predict that, you can make sure that the most important information or controls are in that place. A little bit jump back to cognition. Some of the cognitive components, you can go back to a GOMS thing if it helps. Some of the cognitive steps or tasks that you will be doing in a visualization is diagnostics, monitoring, planning, and exploring. Those are the main ones. You're going to be looking at a visualization to diagnose something or to detect something is wrong, or you may be looking to monitor. You're just exploring and want to be, or that's not the right term for that because there's another one that's exploring. Monitoring, you're watching to see if something's going on. Nothing's wrong now, but you just want to be aware if something does. It could be something that you have to do every day for your job or something. Monitor, make sure this line is above a certain curve. Planning, so the interactability of visualizations enables you to sometimes forecast or explore different data scenarios and make plans or adjustments from that. And then exploring, so sometimes people will get to visualizations and they truly just want to explore. They want to click around and get a feel for the data. Visualizations are highly, highly powerful when used for exploratory data analysis. It's a quick way to make sense of your data analysis. There's been a lot of times where I get handed a giant pile of data and make sense of it, and I will immediately just start making random charts or graphs or load it into a visualization software and start seeing what goes together and what doesn't. It shrinks your analysis time by many factors and can make you a lot more effective at processing data and understanding the story of the data. Different types of dashboards. So visualization software that you might use. Excel can do, charts and graphs. Those are still visualizations. When we're talking about dashboarding and visualization software, we're talking about something that has a little more capability. So Tableau and Power BI are the big ones that I think of. Power BI desktop, I believe, is available for free if you ever want to go get it. SAP and IBM have their own, and there's a ton of other ones, a ton of open source ones as well. There's three primary types of dashboards to be aware of. And another thing to keep in mind, the concept of this dashboard came from business intelligence. So we're looking, when you explore these, you're going to see a lot of finance data or accounting or sales. So that's very, very common for these. So that's why they're couched in this way, like tell you what's happening now, track KPIs, and then process data to identify trends. Those are all aspects of business intelligence and goals of dashboards. So how would Nuclear use these outside of a standard BI environment? So one of the areas that we're exploring is the use of overview screens. So as you've all seen with images of horribly anxiety-inducing nuclear control rooms, what if you could condense all that to an overview? That's what a dashboard is. A dashboard is fundamentally an overview of a bunch of information. So we're exploring some of that here at the INL can we use dashboards to serve as overviews of different processes. So you're never going to use them as a control system, but can they still tell you things about the plant? If you want to adjust in time or ahead of early detection, diagnostic analyst or something, they can see if things are going wrong before we get an alarm or something. Those are aspects, but there also might be others. So ask yourself that, what are some other areas you might use it in nuclear? Data modeling. So this is a picture from Power BI. Every system handles data modeling a little bit different, but the fundamental concept is the same. You are integrating different data tables via various joins to ensure the visualization can pull what is needed from each table to tell your story. So joins, what we're talking about there, this image might be kind of small, but some of these little arrows you'll see are pointing in specific directions. That's, and there are three types of joins: inner, hours, or mixed. And You can explore those on your own time if you want. We're not going to spend a ton of time on joins. It's more of like a data science or data processing question. And honestly, they are, at least for me, they're kind of tricky to get the hang of. But essentially, the idea is you get two data tables. They have different information in them, but they have some commonality. Let's say they have a date table, and they're all pulled from the same date framework. The data matches, so it's compatible. So you can join two data tables by anchoring on that date. If it's a unique identifier too, that's another one. You'll see like order ID or something might be, or product ID or SKU that might be the main things that are anchored there. And then you can pull another data table in and essentially merge that with the data that you have. It doesn't actually merge it in terms of you're not creating one single spreadsheet to run everything. It just handles those representations for you so that when you're building a visualization, you can bring in those relationships with you. Now, some modern improvements or changes to chart design. When we think of charts, right, we think of pie charts or bar charts or lines and all those fun things that were in Excel. Number one, pie charts are terrible. Don't use pie charts. And if somebody tries to use a pie chart with you, you don't need them in your life. Just leave. Just pack your stuff and move away. But there are very few instances where a pie chart is useful. Now, why is a pie chart not useful? It comes down to the way our visual system handles information and how we handle comparisons. Pie charts are useful to see this section of the pie is bigger than these other sections. That is an immediate judgment we can make. So what? All that tells you, all your visual system knows and that you process is this one's the big one. Sometimes, depending on it, you might get a second one, the second biggest. But outside of that, you're not getting any information. If you're using a complex data set, a pie chart's going to have so many slices and not be very useful. Now, it's usually one that's worthwhile to click through as you're exploring different chart options just to see if anything crazy stands out, has happened. But in general, you can represent that data much more effectively in other ways. This is an example of a ribbon chart. They can get kind of messy. They have some, obviously, they have some similar, I guess, you're able to compare things in some different ways because we have connections, which we fundamentally understand by a color in those things, but also the width of the ribbon of the line may be telling you a quantity or a value that is important. So for example, we know this, North America, this is from a Boeing traffic dashboard, if I remember right. I think it's one of the ones we're going to go through. So look, North America to North America, a lot of traffic goes there. Now, if we need any more information, that's something we want to look at. Odds are, though, we probably know this. So what's interesting? It might be, hey, odd, Europe to Europe, big bar, China to China, big bar, North America to North America, big bar, Middle East, no. Middle East flies to Europe more than it, or vice versa, more than we see to itself. There are some of those interactions that we might think are interesting. And remember, at all times, we're trying to exploit visual processing power. So now we're taking a digital field trip to my Firefox window to see some dashboards in process. Now, one nice thing about modern dashboarding, Power BI, Tableau, and a lot of these are available when you can actually embed the dashboards and web pages. So you can explore different galleries and examples, and they'll be live. They're not just a JPEG that somebody had to snip out of a file. So let's go over to that. So Boeing current market trends. This is the one we literally were just looking at. So let me see if I can, does this work? Yeah, Mac Life. So what does this tell us? You know, what are we thinking of? So an interesting one. There we go, it refreshed. Cool. So, because it was only selected. So, okay. A lot of GDP, traffic, are these clickable? No, we can't interact with these. So we just know these are readouts. Okay, single aisle. A lot of people fly on single aisle. Oh, that looks like that's a jet type apparently. World deliveries, world market value. I still think it's strange that they call people flying deliveries, but I guess it makes sense. Here we go, total fleets. This is when we're talking about industry growth, regional contribution to the size and share of the world's fleet. North America is still pretty big. So look at this. See how that just happened? This is a hover function. We're used to these. We're used to this in all websites, right? You hover over a thing, you get other information, usually. You can define in your dashboard what pops up here. And we'll see some different examples of that. Odd. This is not interactable. Why is that? Most of the time, your data is messy and not clean enough to show this. To get things like this that are really connected, you usually have to have some pretty good data. And data is generally not pretty good. So here we go. We're hovering. Oh, and look at all that. It changed the whole dashboard. This is an example of a hover brush. It's kind of a mix of two. You're hovering, but it's brushing. Brushing is fundamentally when you interact with an object and it changes the other visualizations to reflect that. So here's an example of pie chart use that is not horrific. These are called donut charts is the way they stand now, where we've got this little thing here. They're a little bit better than pie charts, not by much. So we know 41,000 deliveries total. Great. What if we hover? We get 72% of deliveries. Now, why does that matter? Well, it doesn't tell us anything about the remainder. What it does tell us is this of 41,000 deliveries. Sure, we could have this report what that number is, 72% of 41,000. Do we really need the number though? We probably just need the ratio. Just keep in mind of that. Another interesting takeaway here is how it affects this market value. So these are intrinsically linked. You hover, you get 70% deliveries, so 53% of market value. So that's an interesting thing. Why that? I don't know, but you might want to click around and see. So that's another aspect of that that could be important. When we go up to regional outlook, you usually have multiple pages of a dashboard. So we are selecting North America. If we want to select a different one, then the whole thing will change via that interaction there. We also can see traffic flows. You can use in a lot of modern dashboarding software, Power BI, Tableau, you can embed different map aspects in there, which is super useful if you're trying to use geolocated data. So here's an example there. Now, this shows a couple different things, right? We have colors that are legend. So the type of flight is, or the connection, North America to Europe for this example, right? That is colored in a certain way so that you can separate it from the pack. The thickness of the line is also a factor. Usually it is representative of value. There was more in this one, which makes sense. We have 19% of all flights from or within North America, 19% of them ended in Europe, 41% of them ended somewhere in the US. And then traffic flows, this is what we already saw. Some examples to this is showing you some breakdowns of specific, I'm going to guess these aren't airports, but they might be actually. This might just be international airports. Yeah, probably. Because you have Row, I believe is Heathrow. I'm not positive. I think it is. Chicago to Chicago, maybe. Yeah. See, when we're hovering, we're getting various interactions there. You can also hover over this. Now, one thing this isn't doing is click brushing very well. So usually when you select one thing, well, that's China to China. Rest of world, not Heathrow. See, learn something every day. So that's how these work. But usually when you click these, everything will change. They're just not connected in that way. Not a bad thing, just means they're not. So we're going to switch to the next one. Where machines could replace humans. This is an interesting one. So this is a McKinsey study, which of course means it's trying to put people out of work. I'm kidding. So worldwide potential for automation employees across all sectors. This is a geographic question, at least the way this is a heat map is explaining. Or sorry, this is a tree map, not a heat map. I think tree map and heat map always got messy in my head because I almost never use them. Nope, it's a tree map. There's one right there. You can also look by geography, which I'm gonna guess is gonna load a map. Let's see, with some dots. Just coloring the whole map. Okay. Now, one critique I have with this, don't use shades of blue. Use other colors. It's really hard to tell these two apart, for example, when you're looking at this scale. Now let's see if the rest of this works. So see a highlighted brusher down there. Let's see. Do we see these change? Yes, we do. So this is an example of a brush that actually works across, and it also functions as a slicer. So what's a slicer? Also, if you ever click one of these and it brushes the whole thing, you just click it again and then it'll wipe it. I'm going to go back to the tree map. I think it's easier for the visualization to manage. Up here, slicers are usually drop downs or check boxes, various things, and they will usually be up in the right or on the sides. They look like sort or filter buttons. We are slicing the data along some line. So if you want to look at employees, this is what we get. What if you want to look at wages? How much money will automation cost, save, or what's involved there? Everything changes based off of that. That's an example of a slicer, something like this that filters. Technically, brushing is a filter as well. So you can see there's some overlap there. Here's an example of one in Power BI. This is one that I really like, and I'll show you why. So up here, select measure. We can select profit, quantity, revenue, perspective. What do we want to look at? Which order category or order type? We can pick those. What I like about this one is watch. So every other time, right, we hover, we get like here. Let's see, get that up again. Come on. It was just doing it. There we go. This is a common hover you'll see, right? A little pop out, little data label, couple bits of information, not a ton. Measure type YOY. If you ever see YOY like that, that means year over year. So what has been the change from last year to this year? Now, I said you can define what shows up in this. That's extremely powerful for some things. So imagine if you're designing a control system and you have a component on your display, you want to be able to give the user a lot of contextual data without a ton of work on their end, What happens if we hover over this? We get an entire full crosstab data. Crosstabs are just a fancy way, probably made up by somebody, to say a table. And they're usually linked with that, and they cross different tables. Like that's probably realistically where the name came from. But so they defined this, and that is extremely useful. A little bit more data than what you'd see on a hover, but they obviously had a reason to design it in this way. We go back over here, we see a normal one. That's one thing to look at. I love that. I love this table for that specific reason. Now let's see how the brushing works. Everything's active, which is nice. That's almost always the first thing I do when I check one of these is I want to click around and see if it's all connected or not. Again, doesn't necessarily mean anything wrong if it's not connected. There's some really good reasons to not connect that stuff. But usually it shows some data work and some other things to make sure that it all played nice. Here's another one. This one uses cards in a good way. These little just random call outs, like you have a title, some number, and then I don't know why it's misshaping, it's hiding that goal text. These are cards. They just tend to have a certain look to them, but they're really, really good for if you have top line information. So from a nuclear perspective, what we want to see. We might want to see power generation. We might want to see revenue, maybe. We want to see downtime. We want to see efficiency, reactor power. There's a lot of things there. Over here, here's some slicers for you. You can select different aspects, and everything changes. So slicers and brushing are important when I say, are they connected? That's a data modeling question. So in that previous slide, when we looked at these data models, your slicers and brushes operate primarily along these pathways. So they're important to keep there and keep in mind. Oh, clicking this doesn't minimize it. Interesting. Okay. So this is another one. Let's see how the hover is. Pretty good, basic, but that's not necessarily anything wrong. Gives you some immediate information if you need. As you're going around there. So yeah, that's interesting. And all these are publicly available. This is in the Data Stories Gallery on the BI community page. Iron Viz. So this is a fun one. If you ever want to look at really creative ones, look at the Iron Viz. You can just Google them. They have it every year. It's a competition that they do at Tableau Con every year. Now, one thing you'll notice with the Iron Viz, so the way it works is a few people are selected, they go up on stage, they get handed a data set, they have to create a visualization live on stage right there. And they have a Power BI or a Tableau expert next to them to help them with any weird quirks. Generally, they're Tableau masters anyway, but just in case they were in anything. But the data is curated and it's usually for a specific thing. You're trying to tell one specific story, and they do it in very powerful ways. That's different than what we've already looked at with some of those business dashboards. They're just trying to give you that overview, and they're just trying to speak kind of across a general perspective of an industry or of a business. Iron Viz visualizations will be a lot more specific. And some examples at Iron Viz for Iron Viz 2019, the 2020 ones haven't been released yet. It was about, I believe it was about food consumption and that in the US or in the nation. Yeah, so here we go. So these are the two, they both won. So this one was Hashem Isa. I hope that's right, I'm pronouncing that right. So diverse versus traditional. So this is a breakdown of cuisine in different areas. See what the United States looks like if we click there. So look at this. This is a very complex multi-tiered visualization, right? We have this immediate graph, right? It says, okay, drag the slider above to take a journey through the data and discover the world's culture. Smart, yeah, 13. What's this mean? If I go down to 7, I don't know what 7 means. Seems like a bad way to do that, but Turkey is the exact mirror of Italy, significant national identity with very low culinary diversity level. So is this the diversity level? Let's change it one more time and see what it says. Interesting. I don't know what this number is supposed to denote. Let me go back and see if it changes. It must be this diversity level. So that must be an arbitrary, or I don't know, they could have given that. There could be something that specifically uses that as a aspect. So anyway, over here, right, this is stacked. How? We have a bar chart with a ribbon chart and a line chart, or a scatter plot all at once. So this, and they're connected here. Italian cuisine's dominance in Brazil, 34%. Japanese cuisine dominance in Japan is 57%. That's interesting. French in France, 79. I'm going to guess this one up here is going to be US. No, it is Turkey. Spain, Mexican, Italian. Wow, I was thinking we'd be a lot lower. But I guess that makes sense. You know, American cuisine is not exactly a main thing there. So interesting. 20% in the US. So this is an example of to tell that story. Now, another one here. Excuse me. So American cuisine includes diverse cuisines around the world. So a count of international cuisine restaurants. Oh, Here's another one you'll see that is really, really neat. So this is a map. This is technically a map. It's just stylized, right? With some color changing variables and a bar chart embedded into the little image here, which is really neat, the image of the state. And when you hover, you actually get the bar chart as a pop-out. Let's look at Idaho. So we have 576 international restaurants, which is 12% of all restaurants. We don't have, so these are all relative to national average, it looks like. We have less European and Asian restaurants than the national average, more Latin American restaurants. So that's kind of interesting. I don't know why Nevada's right here above Utah. These maps aren't always perfect, but so that's an interesting way to do it. And let's see, Latin American, so that changes everything. So Brazil represented 64 in US restaurants, Argentina represented 22. So yeah, those are interesting there and how that works. I pulled up a couple of other ones just to look at. Digital gender gap. Interesting. Okay, so let's see. Across world, men still have far more likely than women to have access to the internet. Oh, that's what this is. So access to people. Internet users, gender gap. Interesting. So this is an interesting visualization to pull up and play with. And obviously we can take certain conclusions from these things, right? So no gender gap is this line. Then we have this normalized curve, it looks like. Looks like no gender gap. Internet users is a percentage of household and gender gap. So this is going to be like our hope, I guess. Interesting. Kuwait, Bahrain, Saudi Arabia. That's an interesting amount of gender gap considering the Middle East there. That's interesting. Sweden, Canada, Qatar, Lebanon, US. Where this is doing it off of households, if you have traditionally heterosexual couples, that might be accounting for some noise in the gender gap data too. Unclear. Oh, and there's your color code. And so you have these little squares, circles popping up. Those are anchor points in the data. So if you click those, does everything change? It should. The other thing that sometimes will happen is that you will see an adjustment when it goes onto these websites. Sometimes when they embed, they lose some functionality. But yeah, interesting. I tried to pick ones I didn't look at before. What is this? Optimize your fulfillment logistics with a single dashboard. Okay. Oh, yeah. So I came from trucking once upon a time, so I'm very used to these. This, that iconography. Oh, this is probably Google Maps. Yeah, it is. Right there, view your directions. So click a city for directions, for example. Delivery cities from a Detroit fulfillment center. Let's go to, also these are going to be names of delivery cities from that fulfillment center. We find a big one. Seeing it's a lot of times these are anonymized, right? So I'm trying to see if I recognize a city. West Hampton. So you click that, what happens? Miles from, tonnage, okay, filter distance, filter tonnage, interesting. So this is looking at different logistics. Odd, the map didn't update, interesting. What do we have here? We've got weather. Oh, so look at this. This is actually pulling weather details at whatever the time this was. Oops. That's changed interaction. And overlaying it on your map. So you could see if there was a weather system where you're going to be delivering. So if you click here, interesting. So yeah, that's pretty cool. So as you can see, you know how some of those interactions work and that you can also get a sense for how we visualize information in that. I guess, you know, from like a Slack perspective, try to look around either at the Power BI gallery or maybe at Tableau Public is another place. There's public galleries for Tableau. or just explore and look at different visualizations. This is a great time to do it because actually I wanted to do this. COVID. So COVID dashboards are all the rage right now because obviously we need to visualize that data. Oh, look, Google has their own. Let's see what Idaho has done. I will be totally forefront. I traditionally am not very impressed with the digital things that we do in Idaho, but I could be wrong. Immediately, I would say stop using Times New Roman on the dashboard, but to each their own. Okay, we're using shades of blue again. I would rather see bars, but I understand why, it's a continuous value. You're just arbitrarily binning them if you say this is blue to blue or one color blue to one color blue, because this dynamic shading can sometimes be difficult. Luckily, we don't have that, the scale's not bad and we don't have that many unique items. Imagine if we had a bunch of little counties, though, it might be hard to see. And it goes to white. I tend to like blue to orange. That's the default for Tableau. Green, it avoids color blindness and, or at least most instances of color blindness. Now let's see how it brushes. Oh, it doesn't to this one, no worries. Let's unclick that, okay. Total people, interesting. So people vaccinated. Okay, so 284,000 people have been vaccinated, but okay, so is it adding these two? Appears to be. So 284,000 people have gotten something. What happens if I click that? Does anything happen? Nope. Let's do this. So this is an interesting example here. Look at this. People who are fully vaccinated or who received one dose. So look at this. This is duplicative of this. Just make one of them. You don't need radio buttons if you can just make this do it. Does that make sense? Now you want to try to make it as easy on your users as possible. Let's see if they did the radio buttons right. Can I unclick it? Let's see. No, did I click too many times? I cannot unclick the radio button. It's a problem with using radio buttons. You usually can't, which is a problem because now I have to reload this page to get it back clear again. Or does this do it? Nope. Okay, that's interesting. Let's look at trend data. Okay, what's your pop out? Just cumulative? Huh? Cumulative is interesting. What if we're interested in more information though? What if we want average? What if we want all that? You always want to give your users more access to the data. Dose one. So interesting. This is another design flaw, I would say, right? This is above this chart. So I thought it would affect this, or it's between them, so maybe it affects both of them. I still would keep it up there, but okay. It doesn't, it only affects the top one. That's weird. You usually want your controls and stuff up top. That's where people expect them to be used. Statewide demographics, pie chart. I hate pie charts. You don't need this. You can just, you could tell the story either way. You could also just have a card that tracks the value. Why are we giving you 2 decimal points? I don't care about 2 decimal points, round up. Let's see here. Does this change anything else down here? No. Again, why? What if I want to see age group 30 to 39 and their demographics? None of this changes. What if I want to see vice versa? Again, it doesn't change. So keep in mind this. This isn't, hopefully this is not coming off as an attempt to dunk on these probably overworked people that have to suddenly learn Tableau in the midst of a pandemic. I don't envy them. But it is one of those things of, hey, if you're going to do it, just try to do it right. I also would greatly imagine that that the data behind this is not great. Let's see. So, oh, I did not talk about this. That is my mistake there. Hold on. Executive Insights. That was the one we were looking at. I want to show you guys another interaction that I didn't. It's called drill down. So, or show data or whatever. I mean, fundamentally what you're doing is you're looking at the data. So you can usually click a value. Come on. It's still loading in, so I'll give it a second here. Okay, shows the table. There you go. You can see your crosstab here. And then I doubt it's up here because this is also not a real business. So usually can drill down within this and maybe explore the data further if there's some transformations of that. Sometimes you can see those. So if we want to look at that for Idaho, right? Thank you, Zoom. I just need my toolbar. I don't need you to come down here. If I want to see the data in Idaho County, what in the world is going on here? Oh, so it's not walking you through it immediately. Why latitude longitude? What I don't understand this. This is odd. Oh, it's only one row. Okay, I suppose that makes some sense. Oh, that's why we're on the summary tab. What's full data show me? Okay. Now, why does this make sense? We're looking to you guys. I'm going to answer my own question, I guess, because this is recorded, right? It's anonymized. It's healthcare data. Healthcare data is usually pretty empty. You usually don't see a lot of novel, interesting things in it because it does have to be anonymized. So, and that's why it also will look processed before it gets to you. It won't look raw. But yeah, that's interesting. So you can explore other states, do different things. Maybe your local health district are doing their own things. Explore other states, what they're doing. I know, and explore interesting design concepts about this, right? So, you know, we're obviously looking at this with nuclear best intentions, but, you know, Florida got in trouble at the beginning of the pandemic. They were representing some graphs that were bar charts that, let's say, showed a decrease in curve. You know, it showed a curve that was going down, so that of deaths, or I can't exactly remember what they were showing. But it was essentially, they were like, okay, we're going to show a bunch of bars and such that, you know, you've got, so you've got, oh, this was a really bad day. Then you've got, we're doing a little bit better because, oh, look, it's going down, et cetera, et cetera. Well, if you look at the bottom axis, these were not consecutive days. It's like the 13th, the 6th, the 5th, the 18th, and it was bizarre. So visualizations are extremely powerful because people will tend to take them as fact too. That's another big one. So you can lie with visualizations a lot, or you can hide information that that then makes me ask why. Like, oh, this makes, why would you not show me the average or something? It's part of that exploratory nature. So anyway, keep that in mind. I hope this was good and helpful. If you have any questions, let me know. Visualization is a fun area for me. It's an area I've been working in a lot, and we'll probably continue to work on it. I'm actually a member of our decision sciences and visualization kind of focus area. So if you have any questions, let me know. And especially if you have questions for something really complicated, or if you have data that you might want some, you know, have some questions on how to analyze it. Power BI or Tableau can be really useful for that. Power BI is free, like I said. Tableau, I once heard, had a student thing. I don't know if they do. When you have to buy it, it's like $2,000 a license. So try to not do that. Anyway, hope it's useful. I'll talk to you guys on Slack. Thanks.